this abbreviation. O, Dr. Cape Town. CPT stands for Cape Town, okay? And then O stands for center. So when there is a center in the question, you must expect the reason. Angle at the center of a circle is twice the angle at the circumference. And when there's D stands for diameter. And when you read the statement, you underline those things. If there is diameter in the question, you simply say angle in a semicircle. And you have to make use of the diameter. Let's say O is the center of the circle, so you make use of the diameter. Let's say AB is the diameter and the C here. So you make use of the two fingers on the diameter and move along the triangle that the diameter makes. So you subtract that angle there at the circumference. And that angle is always 90 degrees because you can see that angle at the center here is half of a circle and is 180. Angle of a half the center is 180, and therefore you can say angle at the circumference is also 90. So here we say angle subtended by a diameter or angle in a semicircle. This is a semicircle. You can see that semicircle is half of a circle, and that is 180 degrees. So now we said on R stands for radius or radii. When you come to examine, let's say they give you in the circle below AOB is given, such that OA is equal to OB. That means you are moving from the center to the circumference. You are from the center to what? The circumference. So both lines are radius, that is radii. Always, when you see radii in a diagram, try to check, does it form a triangle inside the diagram? If it does, then it means that that triangle is what type of a triangle? An isosceles triangle. It is an isosceles what? Triangle. So, if you are using isosceles triangle, then it means this angle at the base here and the angle here will be the same. So, if there's any question, let's say they have given you here to be 100 degrees. The angle in the center is what? 100 degrees. But because you see we have OB, which is radius, and OA, which is also radius, connected to the line AB, which is the chord. It forms an isosceles triangle. So if they ask you to solve this angle, say 8, examiner will ask you to calculate the size of what? Angle A. You will simply say 180 degrees minus 100 degrees divided by 2. And then what is the reason? You can say, when you say 180 minus 100, what is the reason? It's sum of angles in a triangle. And then 180 minus 100 is 80. 80 divided by 2 will give you angle A is equal to 40 degrees. Angle A is the same as angle B as well. So angle A is 40 degrees, and your reason will be angles opposite equal sides. Angles opposite what? Equal sides. Or you can say base angles of isosceles triangle. Or you can say what? Base angles of isosceles triangle. Don't write in full sentence. Isosceles triangle is isosceles triangle with a smaller triangle there. So that's it. So now we move on to the letter C. The letter C. When we talk about the letter C in Euclidean, C stands for cyclic quadrilateral. It stands for what? Cyclic quadrilateral. C stands for cyclic quadrilateral. And then the cyclic quadrilateral has got 3 reasons. It has how many reasons? 3 reasons. So anytime they tell you in the diagram below, PQRS, 4 letters, is a cyclic quadrilateral. You underline the word what? Cyclic quadrilateral. And you ask yourself, why did the examiner say this is a cyclic quadrilateral? Anytime you are solving a question, ask yourself, why did they mention this to be that? What are the reasons behind it? Cyclic quadrilateral has got how many reasons? Cyclic quad has how many reasons? 3 reasons. I said it has how many reasons? 3 reasons. So any of these reasons can be associated with the diagram. Number 1, opposite angles of a cyclic quad are supplementary. So we say opposite angles of a cyclic quadrilateral, and it is examinable for you to learn how to prove this one. Of a cyclic quadrilateral are supplementary, means it adds up to 180 degrees. In exams, if you are writing reasons, you don't write it in full sentence. We just say opposite angles of a cyclic quad. In exam, this is how you give your reason. Opposite angles of a cyclic quad. Now, what does it mean to say opposite angles of a cyclic quad? A cyclic quadrilateral is a quadrilateral that has been drawn inside a circle. It's a quadrilateral that has been drawn inside a circle. A quadrilateral is a plane figure bounded by 4 sides. Bounded by how many sides? 4 sides. So if the circle is drawn around it, then it becomes a cyclic quadrilateral. So now when we take A, B, C, and D, opposite angle. So if I stand in the corner here, my opposite is that corner. So face me, I face you. The angles facing each other is what we call what? Opposite angles. So it means here that angle A plus angle C will give us what? 180. Or angle B plus angle D will give us 180 degrees. And this is examinable. So I'm going to prove this, then I can move on to the rest of it. This is examinable. Examiner can give you this to prove 180. And so you must learn how to prove opposite angles of a cyclic quad. Then from there, I'll talk about the rest of them. So now let's say we are given this circle and we are supposed to prove that opposite angle of a cyclic quad are supplementary. So I have this diagram here. The center is O. You can see most. So I have say P, Q, R, S. And the examiner tells you to prove that. Examiner says prove that in the circle below, O is the center. P, Q, R, and S lies on the circumference of the circle. Prove that angle Q plus angle S is equal to 180. They can ask you also to prove that angle P plus angle R is equal to 180. So that one, they can just say prove any two opposite sides to be 180. It is your responsibility then to learn how to prove it. In this case, you will need to do construction. You need to do what? Construction. So you take your pencil or whatever you are using, and then you will do your construction. How do we do the construction? We are proving Q and S. So you construct from P and R. Are you hearing me? If you are proving Q and S, don't touch Q and S. Touch the ones that you are not proving. So you join a line from here, you join it this way, and you also join it that way to that point. Then it creates two angles, one here and one there. Can you see that? So you can call here, say, O1 and here as O2. That is your construction. So in your construction, write it down. In your construction, you will say join P to O and O to R. So when you join like that, you create angle O1 and angle O2. So now we are going to talk about angles here. So now you have a statement and a reason. Are you with me? So when I take this arc here, the arc PR, it forms this angle O1. Are you following? The arc PR forms angle O1. Angle is formed when two lines meet. This is angle O1. And then angle O2. Can you see that? So the arc PR forms angle O1, and at the same time it forms this angle on the circumference, which is Q. So we will say that angle O1 here is equal to 2 times which angle? Angle Q. Is equal to 2 times which angle? Angle Q. Reason? Angle at center of a circle is equal to 2 times angle at circumference. Is that right? Okay. Angle at the center of the circle is equal to 2 times angle at the circumference. Then we will talk about angle O2 also. Angle O2 is equal to, when you take this arc from here, it's the same PR, but you take it from the top here to here. Then it subtends this angle O2, which is this angle, and it also brings you down to the circumference this way. So angle O2 is equal to 2 times which angle? 2 times angle S. The reason is the same. Angle at center of a circle is equal to 2 times angle at circumference. And so now, with this information, we can now say, but what? When you look at this angle, they are revolving around a point. This is revolution, eh? Yes. It's angles around a point. It gives you, so you can say, but angle O1 plus angle O2 together. When I combine it, it gives me what? 360 degrees. Your reason is angles around a point. Angles around a point, or you can say rev. You can say rev. It's either you choose between the two. Ne? So if O1 plus O2 is 360, what was O1? O1 is 2Q. O2 is 2S. So I can simply say 2Q plus 2S is equal to 360 degrees. When you have something that is in common, you take a common vector. So what is your common vector here? Our common vector is 2. When I take 2 out, what is left here? Angle Q plus angle S in bracket is equal to 360. So I'm solving to get 180. I divide here by 2, divide here by 2. Therefore, what do I have? Angle Q plus angle S is equal to 180 degrees. This is how you prove angle, what you call opposite angles of a cyclic quadrilateral. That's supplementary. It gives you 180. So when you are asked to prove this, you just have to check which two opposite sides am I proving. Don't touch it. You go and touch the ones that you are not proving and join with those constructional lines to the center to meet them. Then you create angle O1 and angle O2. So when you are O1 here, O1 is facing this up. O2 is facing this angle. So angle at the center here is twice the angle here. There? So you say O1 is equal to 2 times angle Q. Angle at the center equals to 2 times angle at the circumference. And then you say O2 is also 2 times, O2 is facing this angle down. So O2 is also 2 times angle S. Angle at the center twice the angle at the circumference. And then you say O1 and O2 is revolving around a point, revolution. O1 plus O2 is 360 degrees revolution. And then your O1 was 2Q, your O2 was 2X, so 2Q plus 2X equals to 360. Then you take a common factor alpha. What is the common factor? 2. So what will be left? Q plus X in the bracket is equals to 360. We want to prove this. So whenever you want to get 180 from here, divide this side by 2 and that side by 2. So Q plus X is equals to 180. Then that theorem is proved. This is grade 11 theorem, and you are going to prove 4 grade 11 theorems, and then 2 from grade 12. But out of the 4, it's not all the 4 that will be coming that proof. They will bring one and say proof. So every question they will take one, and they can take one from grade 12 for proofs. The rest we just use it to solve questions. Yeah. Any question? So now we can move to the second reason for a cyclic quad. I said there are how many reasons for cyclic quad? 3 reasons. 1, opposite angles of a cyclic quadrilateral are supplementary. Don't forget that. Number 2, we have what we call exterior angle of a cyclic quad. Exterior angle of a cyclic quadrilateral. I'm giving you in full statement because they can ask you to continue. Cyclic quadrilateral is equal to the opposite interior angle. To the opposite interior angle of the quadrilateral. Interior angle of the quadrilateral. Exterior angle of a cyclic quad is equal to what? The opposite interior angle of the quadrilateral. So let's say I have a quadrilateral. Okay. And I extend this angle. So I have P, Q, R, S. I have S1 and S2 because there are 2 angles on S. So now in this case, this is a quadrilateral. When I put the circle around it, it becomes a cyclic quadrilateral. Now there is an angle that is going outside the quadrilateral. This angle here is equal to the opposite in interior angle. So angle S2, in exams, if they give you S2, S2 is the same as angle what? Q. Reason? Exterior angle of a cyclic quad. That's how you answer it. So whatever the number here, if the value here is 100, so if the value here is 100, inside the quadrilateral Q is also 100 because they are equal. Exterior angle of a cyclic quad. So if they give you a cyclic quadrilateral diagram, check for these 3 reasons and see which one is in existence to that question. Okay. Now the last one, number 3, is angles in the same segment are equal. Angles what? Angles in the same segment are equal. So when you see a quadrilateral or a cyclic quad, so let me have a circle. Something like this. Yeah? So if I have A, B, C, D. Angles in the same segment simply means angles that are like subtended by the same arc or a chord. Let's see. The arc AD here. If I put my finger on the arc AD and I'm going to the circumference, if I'm going to the circumference, where does it take me to? It takes me to B. The arc AD. To form an angle with the arc AD, one finger on A, one on D. I want to go to the circumference, that means on the circle. They use the 2 lines, this one. Oh. This one and this line are formed by this arc. The same line here and this one are also formed by that arc. So these 2 angles are equal. Angles in the same segment. Angles in the same what? Segment are equal. So here I can say angle B here is the same as what? Angle C. Reason? angles in the same segment. So when we talk about cyclic quad, you must expect these reasons. If you find this shape there, it means the diagram is a cyclic quad. Is that the only angles in the same segment? A and G. So when you are doing Euclidean, don't look at the question with a stiff neck like a giraffe. Don't do that. Switch, turn the papers, rotate the paper, rotate. And then, if the paper is written in portrait, rotate it and see the diagram. Rotate. Don't sit like this because sometimes the pictures are not clear. Né? So once you rotate the diagram, then you'll be able to see clearly all the pictures inside the diagram. So angle A is also equal to which angle? If I'm using this arc here on top, it takes me to D, it takes me to A. So angle A is equal to what? Angle D, same reason. Angles in the same segment or angles obtained by the same arc. So that's what we have for cyclic quadrilateral. There are three reasons. Then now, so we're done with cyclic quad from Dr. CPT. What else is left? P. And then we go to T, and then you solve questions. So P in Dr. CPT stands for parallel lines. You see, examiner likes to bring parallel lines in the question, and they don't put it there for fun. They don't put it for deco. When they put parallel lines, you still not okay. When they put parallel lines, it has reasons why they put them there. So when lines are parallel in a diagram, especially in Euclidean, the moment you read the statement and it says you line bani is parallel to line what, you underline that because you are going to use it to bring reasons. When there are parallel lines, there is something you must know. You need to know the parallel lines has how many reasons? 3 reasons. You get what I'm saying? Parallel lines are how many reasons? 3 reasons. 1, alternate angles are equal. 1 is what? Alternate angles are equal. They are equal because line what is parallel to line what. You must write it like this in exams. Failure to acknowledge the parallel lines, if you write alternate angles equal, you get 0. You hear me? So you have alternate angles in a Z shape. In what shape? A Z shape or N shape. This is where we get alternate angles. But as it is now, there is no alternating angles yet because there are no parallel lines. So where there is no parallel lines, there is no alternate angles. So now this line now become parallel to that. That means the corner angles here, these are the only 2 angles we are seeing. These 2 angles must be equal because the lines are parallel. So let's say the line ST and PQ are parallel. It means that we can say angle P is equal to angle T. The reason alternate angles are equal. Then you put this and say the line what? ST is parallel to the line PQ. Failure to acknowledge this, you get 0. If you don't state the parallel lines, everything you say is null and void. So if this is N is the flip side of what? Of a Z. So we have that. Let's go on. Then we have another reason. I said there are 3 reasons with parallel lines. So anytime you read a Euclidean geometry question and they say this line is parallel, when you are about to answer questions, make sure you have used the parallel lines to bring some reasons, because it is the very reason the diagram exists. Number 2 is corresponding angles are equal. Corresponding angles are equal also. They are equal because of the parallel lines. So corresponding angles is formed on an F shape. So let's say I have these 2 lines and then I have a transversal line cut across it. So I have AB and CD, and I say this is parallel to that line. Then I have K, 1, 2, 3, 4. Then I have E, 1, 2, 3, 4. I want us to talk about alternate angles here and corresponding angles here. Which angles are alternating? Which angles are alternating? Let's write all alternate angles here. Alternate angles, what are they here? Angle K3 is equal to which angle? Angle E3. Next, the reason is alternate angles equal. Reason, the line AB is parallel to the line CD. Failure to write that, you are out of order. So this angle is alternating with this angle. Which other angle is alternating? Angle K4 is alternating with angle E2. So angle K4 is equal to angle E2. That is also another alternate angles equal because AB is parallel to the line CD. We got that. And then the next one is finished. There's no other alternate angles. The last one we can look for is corresponding what? Angles. What are our corresponding angles here quickly? Let's write all corresponding angles. So corresponding angle can be found in an F shape. F shape doesn't mean look at F from the perspective you know F. F can be this. If this angle and that angle lies underneath the parallel line, then it is corresponding. F can lie like this also. It's still the same F. If you can flip it, it will become the F that you need. Next, so this angle here and this angle here are alternating. Even when I have something like this, still I see F shape. So F shape doesn't mean look at F this way only. Next, that's why I said flip it. If F is like this, the angle on top of the line is what we call corresponding angles. Do you get that? So here, let's go. Which angles are corresponding here? K what? K4 and E4 are corresponding. So from here we say angle K4 is equal to angle E4 corresponding CORR. Then you say angles are equal. Equal because the line AB is parallel to the line CD. Finish. Is that all? K4, E4 are corresponding. What else are corresponding?
K3 and E1. K3 and E1.
K3 and E1 are also corresponding. Angle K3 is equal to angle E1. Reason? Corresponding angles are equal because the line AB is parallel to the line CD. Which other angles are corresponding? I gave you all the shapes, so look at them. K2 and E2 because it forms another F. So the angles on top of it is true. Angle K2 is equal to angle E2. Now, K2 is equal to angle E2. Corresponding angles are equal because line AB parallel to CD. Which other angle? K1 and E3 are also corresponding. So we can leave it there. I believe we have seen how corresponding angle works. So the last reason for parallel line is co-interior angles are supplementary. Co-interior angles are supplementary. That means they add up to 180. So co-interior angles are found in a U shape. In what shape? In a U shape. A U shape does not mean you must look at U like that. Anything in this corner like this, they are all U. It depends on how or which direction you are looking at it from. So if there are parallel lines like this one and that one, this is parallel to that. You see that? It means the angles here in here, when you add them, it must give you 180 degrees. Co-interior angles are supplementary because the line Vani is parallel to line Vani. Together? Simple. So that is all about parallel lines. The last one about the Dr. CPT is tangent, T. T stands for tangent. Anytime you read Euclidean and you come across the word tangent, you need to underline it. You will use the tangent to bring some of the reasons in the question. You understand that? So when you are given the question, you need to look at what is given to solve the question. Did they tell you parallel lines? If they are parallel lines, what are the reasons associated? Did they tell you tangent? If they are tangent, tangent has 3 reasons. You see, tangent has 3 reasons. It has how many reasons? 3 reasons. One is examinable and you need to prove it. One of them is what? Examinable and you need to prove it. Others are just examinable but you don't prove them. Okay. One is opposite, the one I'm writing. Opposite, is angle between the tangent and the chord. Angle between a tangent and a chord from the same point of contact, is equal to the angle in the alternate segment. In the alternate segment. So this is what we call tan-chord theorem. It is called what? Tan-chord theorem. In exams, when you write and you want to give a reason, you just say tan-chord theorem. Angle between the tangent and the chord from the same point of contact is equal to the angle in the alternate segment. Is equal to the angle in what? The alternate segment. Examiner can say complete the following statement and they give you angle between a tangent and a chord from the same point of contact is equals to, then you complete, is equals to the angle in the alternate segment. You are sleeping. Are you tired? If you are tired, let's stop. Then we continue later. Yeah? Can we pause there? Pause it.